Welcome back to Dr. Liu's VCE Chemistry channel. Today, we'll break down the equilibrium and rate of reaction questions from the 2024 NHT Chemistry exam. My explanations might need refinement, so I welcome corrections or feedback from teachers, parents, or students. Catalysts can't alter the potential energy of reactants or products, nor can they shift a reaction's equilibrium position or stabilize its components. However, they lower the activation energy by providing an alternative reaction pathway, equally affecting both forward and reverse reactions in equilibrium systems. Collision theory helps explain reaction rates for any reaction, not just gases, at various temperatures and pressures. It suggests that a smaller surface area leads to a lower reaction rate, while increasing temperature raises particle kinetic energy, leading to more frequent collisions and a higher proportion of particles exceeding the activation energy. It doesn't affect collision orientation. For a reaction to occur, reactant molecules must collide with kinetic energy at least equal to the activation energy. However, this is a necessary, but not a sufficient, condition. Energy profile diagrams depict the enthalpy changes in exothermic and endothermic reactions. Interestingly, exothermic reactions frequently exhibit lower activation energies than a significant number of endothermic reactions. Let's imagine an exothermic reaction that's already reached equilibrium. At time T1, we increase the temperature. According to collision theory, this will speed up both the forward and reverse reactions. However, because the reaction is exothermic, Le Chatelier's principle tells us that the equilibrium will shift back towards the reactants. This increase in reactant concentration will then drive up the rate of the forward reaction. The Maxwell-Boltzmann distribution curve serves to show how the number of particles in a system relates to their respective energy levels. For this reason, the area beneath the curve provides a precise measure of the total particle population within the system. The equilibrium constant, Kc, is defined as a quotient. Its numerator is derived by multiplying the equilibrium concentrations of the products, each raised to the power of its stoichiometric coefficient from the balanced equation. This definition allows us to write the equation for Kc. We begin by placing 0.25 moles of NO, G, into an evacuated and sealed container, ensuring no NO is initially present. Upon reaching equilibrium, the quantity of NO is measured. This measurement directly informs us that the amount of NO has decreased by twice the amount of NO formed. With the known volume of the container, we can proceed to calculate the equilibrium concentrations of both NO and NO. The final step involves using these concentrations to determine the equilibrium constant for the reaction. When NO is added at time T1, the concentration of NO abruptly rises. This disturbance drives the reaction forward, which then reduces the NO concentration. However, it will settle at a value still above its concentration just before the addition. The section on equilibrium and rate of reaction is worth a total of 12 marks. This includes 5 multiple-choice questions, worth 5 marks, and 1 short answer question, worth 7 marks. This 12-mark section represents 10% of the total possible score of 120 points. Catalysts reduce activation energy for both forward and reverse reactions. Collision theory states that reactions need sufficient kinetic energy and correct orientation. Energy profile diagrams show enthalpy changes, with exothermic reactions often having lower activation energies. Temperature increases reaction rates and shifts the equilibrium according to Le Chatelier's principle. Maxwell-Boltzmann distribution illustrates particle energy levels. The section also involves equilibrium constant, Kc, calculations, and understanding how system changes affect equilibrium. Should you require assistance, please feel free to connect via WeChat or WhatsApp and send an email. Thank you for your attention. Kindly note the details of Dr. Liu's VCE Physics, Chemistry, and Biology channels.